99.99% empty space of atom look solid to us because atom a tiny solar system
At its center is the nucleus made up of protons and neutrons,
and electrons.
so far away that most of the atom is actually empty space. If you could magnify a single atom to the size of a stadium, the nucleus would be a tiny marble at the center, while the electrons would be buzzing around the outer edges. Everything in between? Almost entirely empty. You see, while atoms are mostly empty space,
Electrons are moving very fast, making atom look like a cloud.
think of it like a high-speed fan blade. When it's spinning quickly, the blades appear as a solid disk, even though most of that space is still empty. In a similar way, the rapid movement of electrons creates the illusion of solidity. When you touch an object like a table, what's really happening on a microscopic level is that the electrons in your hand are repelling the electrons in the table. Electrons are negatively charged, and like charges repel each other, just like how the same poles of magnets push away from one another. So, when you push against a wall, it feels solid because the electrons in your hand and the electrons in the wall are forcefully pushing against each other. That repulsion is what gives objects their solidity.
Also, one more fact is that the rule says that no two electrons can occupy the same configuration at the same time.
In simple terms, this rule keeps electrons from crowding into the same space. This no-sharing policy helps create the structure and stability that makes solid objects, well, solid. So, in a sense, when you touch something solid, you're really interacting with the forces between atoms and their rapidly moving electrons, not the empty space within them. It's mind-blowing to realize that what feels solid and real to us is actually a carefully balanced dance of invisible forces at the atomic level. Before we wrap up, here's a fun thought experiment. If you could remove all the empty space from the atoms in your body, you would shrink down to the size of a grain of sand. Yet, despite being mostly empty space, you and everything around you appear perfectly solid. That's the strange beauty of quantum physics at work.